Hello students, today our topic is to find the volume of cube and cuboid. We know that cuboid or a cube is a three-dimensional figure. A cuboid has 6 rectangular faces as shown, with having varied length, breadth and height. This is the length of the cuboid, this is the breadth of the cuboid, and this is the height of the cuboid. With varied length, breadth and height of a three-dimensional figure is a cuboid, exactly like this box. We have the 6 surfaces on that with varied length, breadth. This is the length, this is the breadth, and this is the height. And to find the volume of the cuboid, we have to find the product of its dimensions. Volume of cuboid is length into breadth into height. And for a cube, we know cube is also a form of cuboid, but with all sides equal. We say cube is a 6 square-faced figure with all its length, breadth same as equal to S, or we can denote it by L. Its length, its breadth, its height is same. So the volume of the volume of cube is equal to the product of its all 3 dimensions. If we take the edge of the cube as L, then its volume will be L raised to power 3. So let's take an example about cube and cuboid. Suppose this is the box. Suppose we take its length as suppose 15 centimeter, breadth as 10 centimeter, and height as 5 centimeter. What will be its volume? The volume of a cuboid is the product of its length, breadth and height. Length 15, breadth 10 and height 5. That is 750 centimeter cube. One thing again you have to keep in your mind, that the units used in the dimensions should be same, and if it is not, you have to make it uniform. If we take another example of a cube, suppose edge of a cube is given as 10 centimeter. What will be its volume? Volume of cube is the edge raised to power 3. That's 10 raised to power 3, 10 to be multiplied 3 times by itself, and which is equal to 1000 centimeter cube. So it is clear that the volume of the cuboid is length into breadth into height, and the volume of the cube is the cube of its edge. Let's take some examples from your book. There is a question that a matchbox measures 4 centimeter by 2.5 centimeter by 1.5 centimeter. Let me write this question on the board. A matchbox measures 4 centimeter by 2.5 centimeter by 1.5 centimeter. What will be the volume of packet? Containing 12 such boxes. Now, this is the simple question of a cuboid, where a matchbox is given with varied length, breadth and height. It can be written as the length, we can take it as in uniform sequence, that 4 centimeter might be the length, 2.5 centimeter is the breadth, and 1.5 centimeter is the height of the matchbox. So straight away we can find the volume of matchbox which is of a cuboidal shape. You can write it in brackets as cuboid. So as to you know that the matchbox is having a cuboidal shape. So its volume is the product of all its dimensions, length into breadth into height. You have to keep in mind that the units to express length, breadth and height should be same, and if they are same, then there is no problem with that. You can straight away go for its product. Now multiplying it, we have 4 into 0.5 is 10, into 1.5 is 15. So 15 centimeter cube is its volume. Now, what is the volume of the packet containing 12 such boxes? Now, volume of one matchbox is 15 centimeter cube. Therefore, volume of 12 such matchboxes will be 12 into 15. That is 180 centimeter cube. And that's the question done. Take another question from that. Find the cost of digging a cuboidal pit. Eight meter long, 6 meter broad, and 3 meter deep. At the rate of rupees 30, per meter cube. Again, this is the question of a cuboid, where a cuboidal pit is to be dug with length 8 meter, breadth 6 meter and height 3 meter. So straight away we find the volume of the cuboid. Now, what is the length of the cuboid or cuboidal pit? It is 8 meters, and its breadth, denoted by B, it is 6 meters, and its height, it's 3 meters. Now, what will be the volume of that cuboid? It will be the product of its length, breadth and height. And volume of the pit, which is in cuboidal shape, we have to use the formula for the volume of cuboid, that is length into breadth into height. Length 8, breadth 6, height 3. So 48 into 3. It is 144 meter cube. Now, to dig this cuboidal pit, we need to dig it of 144 meter cube volume. Now the cost of digging is given 30 rupees per meter cube. If you dig this pit, 1 meter cube digging out the earth from that pit costs you rupees 30. So cost of digging one meter cube is rupees 30. Therefore, cost of digging this cuboidal pit, 144 meter cube, is 30 into 144. And put 0 in the end. It's 4,320 rupees. And this is the answer for that question. An interesting question of this exercise. There is a question, a village having a population of 4,000 requires 150 liters of water per head per day. It has a tank measuring 20 meter by 15 meter by 6 meter. For how many days? Will the water of this tank last? Now, this is a very interesting question about the water consumed by a certain village. The tank is cuboidal in shape. Suppose we have this type of cuboidal tank for a village, from where the villagers consume water from that. Now, the length of that tank is 20 meters, the width is 15 meter, and the height is 6 meters. Now, the volume of that cuboidal tank is the volume of the water contained in the tank. And while the water is consumed, it is 150 liters per day per head. One person, either man or woman, girl or boy or child, anyone, consumes 150 liters of water for one day. And we have 4,000 people living in that village who consume this water from that tank. Our question is that, for how many days will the water of that tank last for? So, there is little bit of change in that question. While as the volume of the dimensions of the tank are given in meters, and the consumption of water is in liters. So, liter is one sort of unit and meter is other sort of unit. The relation between the two is made with this relation: 1 meter cube is equal to 1000 liters and 1000 liters is equal to 1 kiloliter. Either we need to change liters into kiloliters to meter cube, or meter cube to liters or kiloliters. So, to solve that question, let's first find out what is the volume of the water tank. Volume of water in water tank is same as volume of water. The tank is same as the volume of tank. So, volume of water in water tank is equal to length into breadth into height. The length, breadth and height have the same units. While calculating, we do not need to put the units there. It's 20 into 15, 300 into 6, 1800 meter cube. So, the capacity of the tank is 1800 meter cube. You can change meter cube into liters or keep it as it is, and after that you can change liters into meter cube. Now, one person consumes water for one day. It's 150 liters. Then 4,000 persons, 4,000 people living in that village will consume how much water for one day? It's 4,000 into 150. It is 6 lakh liters. So 6 lakh liters of water is consumed by all 4,000 people from that village per day. We can convert this liter into meter cube because 1000 liters is equal to 1 meter cube. Therefore, 6 lakh liters is equal to 6 lakh divided by 1000. So, 6 lakh liters is equal to 600 meter cube. The capacity of the water tank is 1800 meter cube and the water consumed for 1 day is 600 meter cube. So, it's simple now. How many days will the water last for? The water will last for total capacity of the tank, the water in the tank, divided by the water that is being consumed in a day. So, we can write it at in that corner, water lasts for total capacity of that water tank divided by the water consumed in a day. It is 3 days. The water in the tank will last for 3 days. Okay? There is another interesting question for you. The question is also related from Cuboid. A river 3 meter deep and 40 meter wide is flowing at a rate of 2 kilometer per hour. How much water will fall into the sea in a minute? Now, if we take this question very minutely, we will find out that this river also makes the shape of a cuboid. If we take the speed of the flowing water as the length and the height and depth नहीं अब कोई बात no problem. Now another interesting question. We have a river 3 meter deep and 40 meter wide is flowing at a rate of 2 km per hour. How much water will fall into the sea in a minute? Now this question is also related to the cuboid. How is that? The depth of the river should be taken as the height of a cuboid, and the width of the river should be taken as the breadth of the river. Now the speed of the water that is given, we will take this as the length of the cuboid formed by the flowing water for a minute. Now, what is the speed of water flowing? It is 2 kilometers per hour. We can change this into meters. 2 kilometers means 2000 meters. If 1 kilometer is 1000 meters, then 2 kilometers is 2000 meters. This is the speed of the flowing water, or water flowing. And how much water will fall into the sea in a minute? Now, if we convert time into hours, 1 minute can be written as 1 by 60 hours. So, distance covered by flowing water in a minute. This distance covered by the flowing water in a minute will be taken as the length of the river. So, it is speed into time. It's 100 by 3 meters. Take this distance covered by flowing water in a minute as the length of an imaginary cuboid so formed. Now, what will be the volume? Volume of water flown is equal to the product of its length, breadth and height. Length we take as 100 by 3 meters. Breadth as 40 meters and height as 3 meters. It is 4000 meter cube. So, how much water will flow into the sea by that river for a minute? It is 4000 meter cube. You can write it as 4000 kiloliters. You can write it as multiplied by 1000. As much liters. I hope you have understood that question, that how this flowing river forms an imaginary cuboid. There is another good question for you. Let me write down that. Water in a canal. (30 decimeter wide, and 12 meter deep. Is flowing with a velocity of 20 kilometers per hour. How much area will it irrigate in 30 minutes? If 9 centimeters of standing water is desired, because the question isn't given in decimeters, we can change it into meters. Now 10 decimeter is equal to 1 meter. So if we take again close look at that question, we can find out that this is also a question of a cuboid. Whereas the velocity, the speed of the flowing water is taken as the length of an imaginary cuboid. A canal has breadth, it has a depth. Now the water is flowing with certain speed, which will be taken as the length and breadth and height. It gives us the volume. The question says that if the water in the canal is flowing with a speed, a velocity of 20 km per hour, and the time of 30 minutes, that's half an hour, how much area of the field will it irrigate if the water stands 9 centimeter in the field? That means if you go into that field, the level of the water will go 9 centimeters up when you walk or wade in that water. Now we can convert decimeter into meter and kilometer as well as meter. Again, it's very important that all the units should be same so that the calculations can be done. How can this question be done? Now take the speed or the velocity, means same one and same thing. Velocity of flowing water as we is 20 km per hour. Now change kilometers into meters. 1 kilometer is 1000 meters. So 20 kilometer is 20,000 meters per hour. Now this water flows for 30 minutes. That change minutes into hours because the speed of the water is given in hours. So we need the time also to remain in the same unit. So time taken. (30 minutes) convert into hours divided by 60. It's 1 by 2 hour. So distance of water flowing in 30 minutes. 30 minutes can be written as 1 by 2 hour, that is 20,000 into 1 by 2 can be written as 10,000 meters. This 10,000 meters is to be taken as the length of the imaginary cuboid formed by the canal. Keep it as L. Now the breadth or the width is the same thing. The breadth of canal, which is to be denoted by B, is 30 decimeter. To change into meters, we divide it by 10 and it becomes 3 meters. Because 10 decimeters is equal to 1 meter. Now, what is the width or depth? What is the depth or height of canal? Can be represented as H, and it is 12. It is 12 decimeters. Yes, it's 12 decimeters. So divide 12 decimeters by 10. It becomes 1 by 2 meters. So volume of water flowing in 30 minutes is length into breadth into height. That's 10,000 into 3 into 1.2 can be written as 12 by 10. So 3 into 12, 36 into 1000 is 36,000 meter cube. So how much of water flows into the field for 30 minutes? It's 36,000 meter cube. Now this water goes into the fields, and where it irrigates as much area of the field that the water standing in the field is at the height of 9 centimeters. We have to find out how much area does this flowing water irrigate. For this, I need to rub that part and to find out. When we let area of field irrigated be a meter square, because area is a two-dimensional quantity to be written as meter square, and the depth of the water remaining is 9 centimeters, which is necessarily to be converted into meters. Now the volume of water in the field, is A into 9 by 100 meter cube. A is the area, two-dimensional, and height, when multiplied by it, it gives volume. So the volume of water in the field will be the same as much the water goes into the field in 30 minutes. So we can equate them. Accordingly, A into 9 by 100 is equal to 36,000. Cross multiply. Transposing. (4,000 into 100) is equal to 4 lakh meters square. Is the area of the field irrigated, and this is the answer. Hope that you have understood the volume of cube and cuboid and the related questions. Thank you.